So let's have a quick recap before we look at binary searches. So if we start with a sequential search, and let's draw out the algorithm very quickly. So quickly set up all the variables we're going to use. We've got the index for the loop. We've set up an array of 10 integer numbers, and we set up a Boolean value that we're going to use for the found flag. I'm not going to individually assign values to each of the elements in the numbers array. I'm just going to draw this in red at the top so you have an idea of what the 10 numbers might look like. So if we say that our numbers array, element 0 is number 14, element 1 is 9, then 4, 16, 8, 3, 12, 18, 7 and 2. So it's an unsorted one-dimensional array, and we can apply a sequential search to this for a particular value. So we need to know the target. And if I set the value of target to 8, so this is a number which is definitely in our numbers array, and we just want to find out if it exists in our number array using a computer program. So we create a fixed loop because we know that there's 10 items in the array. So because we start at the 0th element, which is number 14, and going up to the 10th item, it would be from 0 up to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're looping for index equals 0 to 9. And then for each of the items in the numbers array, we want to compare that to the target. And so if the target matches the current position in the array, then we set the Boolean found flag to be true. And then we just end if and end for. By the time we get to the end of the iteration through the loop, we can guarantee that if we have found any one of the array elements to match target, then the value of the found Boolean variable will be true. If for whatever reason we haven't managed to match target to each of the array elements, then found will be set to false. And so a nice easy way of just outputting something useful to the user is just to output the value of found. Obviously you can add an if statement so that you can actually output more meaningful messages, like if found is true, you can say output I found it, or you can say if found is false, you can output I've not found it. But if we just output the value true or false, it gives the user some feedback. And so this is the sequential search. There are some drawbacks and advantages of this. I'm just going to jot them in red. One of the first advantages is that you're guaranteed that you will find a number or a letter or a word if it's in a one-dimensional array. And the second advantage is that you do not have to sort the array into numeric, ascending or descending order before you search it, because it will test every single element in the array. The downside of a sequential search is that because it will test every single element which is inside the array that you're feeding into the search, it can take a lot of processing power and it can take a lot of time to complete operations. So we need a more elegant solution, especially when we're dealing with arrays of more than 10 items. And this is where binary search comes in. And so with a binary search, there's something that hopefully will stand out straight away. And that is that you need to have a sorted array. it can be 10 items, it can be 1,000 items, it can be 1,000,000 items, but it needs to be sorted into ascending or descending order. Because what we're going to do is we're not going to test every single element in the array, we're just going to test a particular subset. And how we do this is we jump to the middle of our array and we compare the middle value to the target. And if the middle value is higher than the target, let's say the target is 8, if the middle value is higher than the target, then it can be said that it's guaranteed that 8 will not be anywhere to the right of the number, and if it's higher, then it doesn't match up to the number either. So we can reduce the size of the search. We then jump to the middle again and we look at the middle item in the second pass and we say, okay, is it equal to the target? Yes, it is. So we found element 8 in the array after only 2 tests. So if I write out the algorithm quickly to show you how this differs from the sequential search. So here's the algorithm. We've got our target at the top here. We've got some new variables. I've not declared them because there wasn't space. But we've got a variable called start. It's an integer value that holds the leftmost position in the array. So that's position 0. That's why start is 0. And end holds the rightmost position in the array, which is position 9. And we've got our Boolean value as before. Now, this time, instead of using a for loop, which will guarantee to run the exact number of times it needs to run, we're going to use a preconditional loop, a while loop, where we only run or continue to run when found is false or start is less than or equal to end. So 0 is less than or equal to 9, so that's true and that's currently true, so we run this. What we do is we find the midpoint. So there's a nice easy way to do this. You take the start value and you add it to the end value and then you div it by 2. Now div is different from the usual forward slash. Forward slash is a divide which gives you the real value, resulting in a real value. So if you were dividing 3 by 2, for example, with a slash, you would get 1.5. However, div is a special function or operator which returns an integer value, and it will round up any decimals. So, well, if it's over 0.5. So if we added this together and we got 3 div 2 would give you 1 as opposed to 1.5 if you use the slash. So we get a number. Okay, so if we do this as an example, 9 plus 0 is 9, div 2 is 5. So we're looking at 0, 1, 2, 3, 4, 5. So the fifth element in. And then we look and we say if target is equal to numbers 5, for example. So that we know that's 12, so that's not true. And so we don't set found to true. We'll evaluate another condition. We'll see if the target is less than numbers. So that is true because 8 is less than 12. So now we set end to be equal to the position of midpost, which was 5, minus 1, which is 4. And by doing that, we rule out all of the items to the right and the item itself, which was at position 5 in the array, so 5 and beyond. And we continue looping around again. And this time, we set midpost to be start plus end. Well, start plus end is 0 plus 4, so it's 4. Div 2 gives you 2. Okay, so we jump in at position 2, so 0, 1, 2. And we say, is target equal to numbers? Well, yes, it is. So we set find to true, and We go back to our while loop, and now found equals false is not true. That results in a false. But start is still less than or equal to end. So there's a bit of a logic problem with this one. So I think if we just make it an and instead of an or, that means that both the left-hand side and the right-hand side has to evaluate to true in order to continue. And so that fixes our missed logic error there. So now found is set to true, so this is false, and even though that's true, false and true is equal to false. You have to have true and true with our logic gates. And so we jump out of the end while, and then we output found, and we found it. So output will be true. And that is a binary search. The reason we use binary searches is this. If we compare it to a sequential search, we end up with usually about half or less of the amount of comparisons required in order to find a target value that is definitely in the array. But a downside is that it needs a sorted array before it can effectively find the target value.